Here we go. Okay. So here we have these examples where, for each one, identify the most relevant source of bias that can occur. Okay. For instance, if a survey were to ask, should the death penalty be permitted if innocent people might die? Well, hopefully you can tell that that's loaded question. That's a loaded question. Okay. You can see from the wording they're trying to get you to be against the death penalty. Okay. And here's another one. Okay. A survey randomly calls people from the phone book and would ask them a long series of questions. Well, for me, that'd be non-response bias, right? You're going to have people that choose not to respond. It's like Spectrum calling you and asking you, like, a survey or whatever. Or here's another one. A survey were to ask people to report their actual income and the income they reported on their tax form, IRS tax form. Well, for one thing, there might be a perceived lack of anonymity. They might fear the government coming after them because they were not honest on their taxes, right? So that would be a perceived lack of anonymity, or even response bias. With response bias, remember, let's see, where is it? They might give the wrong information for whatever reason. They might lie or they may not remember, that kind of thing. Okay, good. All right. Are there any questions so far? Okay, also note from number 3, sometimes there may be more than one source of bias. Okay, there may be more than one source of bias. So, okay. That can happen though. Okay. All right, so here in statistics, what people like to perform is either an observation or experiment. When they do a study, they could perform an observational study or an experiment. With an observational study, it's really just based on observations or measurements. When they're conducting a study, they're getting their conclusions from observing a sample or even the whole population. I guess it really depends. Although generally I would say they would observe the sample. With an experiment, though, that's like what they do when they test medicine. I'm guessing that's what they did with these new vaccines that are out for COVID. I could be wrong about that, but with an experiment, though, that's how they test the effects of a certain treatment. What they basically do, I think we'll see this more later. What they'll do is they'll actually form 2 groups. One group will get a treatment. Another group will actually not get the treatment. They'll get some kind of, I think they call it a placebo, like a sugar pill or something. And otherwise, the 2 groups are the same. They're subject to the same influences, outside influences, that is. But basically, the 2 groups are the same otherwise. The only difference is one group got a treatment, the actual medicine. The other group somehow did not. They may not know if they got the treatment or not. That's like what they do when they test a pill, like medicines in the form of a pill. The control group would get like a sugar pill. They may or may not know if they got the medicine or not. And the people running the experiment, they'll measure and record everything. For medicine, that's usually what people do when they do experiments. So, again, one example is a doctor might explore the effects of music on temperament and mood, right? By measuring people's treatment while listening to different types of music. That's treatment. The music is the actual treatment, though. Okay. Or here's another one. You might test out a new bathroom cleaner. You might buy a bottle of it and clean your bathroom with it. That would be a treatment. So one week you would maybe clean the bathroom with a new treatment, with a new cleaner that you buy. And the following week, you would clean the bathroom with the original cleaner. Or you might clean another bathroom if you have another bathroom in your house, right? Again, the idea is that they're the same except for the treatment. With the doctor example, the groups would be the same except for the kind of music they listen to see if music has any effect on them. Okay. Okay. You might be thinking, though, why would people do observational studies? It sounds like experiments might be a much better thing to do. Well, usually people may do observational studies because of ethical reasons. For instance, if you want to know the effects of, like, smoking, for instance, would have on people's health, or doing even, illegal drugs or something, like what effects alcohol would have if you abuse it. They're not going to give people alcohol and say, here, drink this. They're not going to have people smoke cigarettes, right? That would be unethical. What they would do is observe what it has done to people who are already smoking or already drinking alcohol before the study. They might do something like that. So for observational studies, that's usually what's done. And again, for experiments, there's two groups of people usually. Again, one group gets the treatment, one group does not. So just letting you know, that's what would happen here. Okay. All right. Are there any questions about this stuff? Okay. Okay. Now with experiments, though, again, you really want the two groups to be the same, except the only difference to be one group would get the treatment, the other group does not, because you want to rule out what's called confounding. You have to be careful of this. That occurs when there are two or more potential variables that could have caused the outcome, and you don't know which actually caused the result. So confounding is you have to be a little bit careful, because with confounding, that can mess up an experiment. That's again when there are other variables there that could have affected or caused the outcome. You might hear about that where, if you go on YouTube and you hear about music that helps people do better on schoolwork or something, like classical music, which is actually the example I'm doing here, that students will listen to classical music before taking an exam, right? And they do very well on the wait, excuse me, sorry, I messed up. Students first take an exam, right? You're doing an experiment. Then students would listen to classical music, right, for a bit. I don't know how long. Then they would take a similar exam. And let's say they do very well on the second exam that they take. One might conclude, oh, well, the classical music does help people do better on exams. Well, you have to be careful. There are other possible confounding variables, as they call it. Like what? Well, for one, the students could be more relaxed. So because they were actually relaxed, that's why they did well in the exam. So it's not necessarily the music. They could have done something else to relax. Also, because they took the first exam, they might be all warmed up, and they might remember now how to do certain problems, the material better. So that's why they might do better on the second exam. So there's other variables there that you have to watch out for. And what I was trying to say on YouTube was that you'll see a video that says, listen to this classical music and you'll do better on your exams. But again, there's really a third variable out there. There's confounding there, right? It's really the relaxation that might be doing it. Or another one might be people take a diet pill to help them lose weight, and after being on the pill for a month, they report that they lost 10 pounds on average. But what possible confounding variables? Well, they could have, changed their diet during that month, right? That's something you would have to account for. They could have exercised, right? Those are confounding variables, okay? So that's something you have to be careful about. All right, we have about 10 seconds left.